This is lesson 2, video 2. We give you a formula up at the top for compound interest, where P is the initial amount, R is the interest rate written as a decimal, K is the number of compounding periods per year, and T represents time in years. Compound interest means the interest accumulated gets added to the total principal, then recalculated, so you're earning more interest. Helen is opening her first savings account and is depositing $500. Suppose she decides on a bank that offers 6% annual interest to be calculated at the end of each year. Number 1. Use the formula above to write a function a of t to model the amount of money in Helen's savings account after t years. A of t equals our initial amount, or our principal, so 500 from right here, times 1 plus the rate written as a decimal. So to go from a percent to a decimal, you have to move the decimal point 2 places to the left. 0.06. K is the number of times we are compounding the interest, so we're just doing it once because it's being compounded annually, so just one time, and then raised up to the K times T, so K is 1, T is T. So there is our initial equation, and then if we simplify this to make it look a little less ugly, we have 500 times 1.06 to the T. On number 2, determine the amount in the account at the end of 1 year. So T is going to turn into 1. So A of 1 equals 500 times 1.06 raised up to the 1. When you type that in, you get $530. Pause the video, try number 3. Now that you've tried number 3, all you're doing is letting the T value be 5. So same equation, but now T is 5. So type that in, you should get about $669.11. 4. Calculate the amount of money Helen would have in her savings account at the end of the year if interest was compounded twice a year. So remember, K is the number of compounding periods. So we're going to need to change our initial equation a little bit because now we're compounding twice a year. So it's still 0.06 in the top of the fraction, but in the bottom of the fraction it's 2 since we're compounding twice a year. So now I'm going to do 500 and then 1.03, because 0.06 divided by 2 is 0.03, and then 1 plus that simplifies down to 1.03 times 2 to the first. Type that in, we get $530.45. Number 5, what effect does the frequency of compounding have on the amount of money in her savings account? So we noticed that if we compound more often, then we get more money, because $530.45 is greater than only $530. So the more frequently compounded, the more money she has. There's a way to calculate compound interest that's compounded continuously. You can click on that link and check it out. Let me see if the link actually works. It might. we're going to abandon ship and not worry about that. Okay, so hopefully that'll work for you. If not, basically the link is just showing you that as you compound interest more and more frequently, it basically leads to this irrational number that we call natural base E. So this number that I'm about to highlight, this is E. So it's an irrational number, just like pi, when you've worked with pi with area of a circle and circumference of a circle. Very similar concept in the fact that it's a number that just goes on forever and ever with no distinct pattern. So the formula for compound interest with continuous compounding can be written as A equals P times E raised up to the RT, where P is your starting amount or your principal, R is your rate written as a decimal, and T is the time in years. Number 6, suppose Helen's investment of $500 in her savings account is compounded continuously at a rate of 6%. Write the equation A of T to represent Helen's investment. So A of T equals P for principal, 500. E is that irrational number that just stays E. 6% as a decimal is written as 0.06, and then T is the time. So that's all they're looking for there. On 7, we're going to just put a 1 in instead of T into the equation we came up with in number 6. So A of 1 equals 500 E raised up to the 0.06 times 1. And there actually is an E button on the calculator. So you want to find that E button on the calculator, type that in, you get $530.92. Pause the video, try number 8. You should have gotten A of 5 equals 500 times E to the 0.06 times 5. And when you type that in, you get $674.93. With number 9, we have Jan investing $1,500 in a savings account. The bank pays 2% interest, compounded continuously. We want to write a function to represent this situation. So A of T equals our principal, our initial amount, the $1,500 that she started with, times E raised up to the 0.02 times T. Pause the video, try 10. So you're just plugging in 7 for the function you came up with in number 9. 1,500 E raised to the 0.02 times 7, and we get $1,725.41 when we type that into the calculator. Number 11, the population of the city of Fredericksburg, Virginia, was approximately 19,360 in 2000 and has been continuously growing at a rate of 2.9% each year. Write a function to represent this situation. So you'll notice with all these problems we've been doing recently, they all mention the fact that they're growing continuously. So that word continuous kind of tips you off to the fact that you're using this equation right here, PERT. So you only use PERT if it's continuous compounding or continuous growth of a population. So back on 11, A of T equals the initial amount, so 19,360, times E to the rate written as a decimal, 0.029, and then times T. Pause the video, try 12. So since T is the number of years since 2000, and now it's 2020, I'm going to let my T value be 20. And then I'll literally just plug in 20 where I see T in my equation. So 0.029 times 20. And you just type that all into a calculator, and we should get 34,578 people. And since we're talking about people, I just rounded to the nearest whole number, since we're not going to talk about like half a person or 0.2 of a person. So I just round that up to the nearest whole number. Pause the video, try 13. With 13, the year is 2032, So it has been 32 years since 2000. So I'm going to let the t value be 32 in this problem. So just take 32 and then plug in for t. And then we type that in and we get about 4897. And again, I just rounded to the nearest whole number since we're talking about people, since it's population.